Okay, we are looking at the next scenario of our final study guide, and the scenario says that you have decided to play parkour, where you actually do an urban obstacle course. You decide to run off a 3.45 meter tall wall with a horizontal velocity of 6.82 meters per second, which means that it goes strictly horizontal and at 6.82 meters per second, and your height from there to there is 3.45 meters. Okay. What is your gravitational potential energy before you jump? Well, I'm going to assume that your mass equals the same mass that we had for you in the last problem, which was 83.7 kilograms. Okay, so gravitational potential energy is mass times acceleration of gravity times your height. And so your mass is 83.7, 9.81 for the acceleration of gravity, and your height, which is 3.45 meters. Now, in this case, you come up with a potential energy of, when you do the math, 2,830 joules. Okay? Now it says how many seconds are you screaming your head off as you fall? So in this case, you are falling and you're trying to figure out how long it takes you to fall. And we are looking at a projectile motion problem right now, or two-dimensional motion. So I would look in there into my foldable and I would find a two-dimensional projectile equation that has my initial velocity, all right? And because we're talking about two dimensions, I need to separate. So my initial velocity in the y direction is actually going to be 0, because that's where I get from this strictly horizontal velocity. So my initial velocity in the y direction is 0. I know that my delta y is going to equal 3.45 meters, because I know I'm falling down 3.45 meters. And so it's 3.45 meters down. And I know that my acceleration is 9.81 meters per second squared down. And that has to do with the fact that all falling objects have the same acceleration. What I want to find out is time. It says how many seconds. So my time is my big question mark. So if I look through my equations, I have delta y equals VIY times my time plus 1/2 g t squared. Well, VIY is 0, so that goes away. And so now all I have to do is rearrange. In order to rearrange and get my t by itself, I need to divide both sides by 1/2 g. And I need to take the square root. So those cancel. And then I take the square root of both sides. All right. And then I'm done. The square roots cancel with my square, and I get t equals the square root of delta y over 1/2 g. So let's go ahead and plug it in. Delta y. Delta y is down 3.45 meters, so that's going to be negative 3.45 all over 1/2. G is down, so negative 9.81. Whenever I type this into my calculator, I come out with my time equal to 0.838 seconds. All right, the next one says how far from the base of the cliff, and I don't know why it's messing up, but how far from the base of the cliff, or from the base of the wall, did I hit the ground? So I'm looking for delta x, or my range, is my question mark. Now in this case, because I'm going strictly horizontal, VIX actually equals my VI, which was, let's go back up, 6.82 meters per second. And I know my time from the previous problem that I was in the air was 0.838 seconds. So the equation, the only horizontal equation I have for two-dimensional motion is delta x equals VIX t. So VIX, which is 6.82 times my time, 0.838. Type those into my calculator, and I get delta X equals 5.72 meters. Okay, and that's the second scenario. Let's look at the third scenario while we're at it. We have a Hayabusa, which is a very large street bike that has initial velocity of 44.44 meters per second to the north. So here's my motorcycle, like that. And we're traveling to the north, 44.44 meters per second. And for some reason, it keeps making those into like 9. So I just won't write the number. So I'm not going to write the numbers because it keeps wanting to touch them together. So let's just look at this 44.44 meters per second to the north, and I have a mass of 260 kilograms. So if a rider twists the throttle and accelerates, so I have this acceleration to the north, what is the net force on a Hayabusa? Well, we know the relationship between acceleration and force through Newton's second law, F equals ma. So the mass of the Hayabusa is 260 kilograms times the acceleration, which is 5.438. And whenever I plug that into my calculator to get my force, I come up with 1,400 newtons north. Now, the reason I come up with 1,400 newtons and why I only have 2 significant digits here is because that 260 only has 2 significant digits. All right, so I rounded it at 1,400 newtons. Okay, so if it takes the Hayabusa 1.38 seconds to undergo this acceleration, what is the bike's final velocity? Well, the bike is traveling in one dimension. It doesn't move left or right. It just goes north. So I'm going to look in my one-dimensional folder or tab in my foldable, and I'm going to come up with something that has acceleration, that has initial velocity, and it's going to spit out my final velocity, and also it has time. So V final equals V initial plus AT, which in this case is going to be my initial velocity, which is 44.44 meters per second plus 5.438 times my time, which is 1.385 seconds. And so I have my final velocity equal to 51.97 meters per second north. And it makes sense. This velocity is much greater than the 44.44 meters per second. So the Hayabusa did speed up. Okay, and then that finishes the study guide. Study it, and I will see you for the final.